So, section 2.6, this is the last one before your test next week. We will do a review on Tuesday before your test on Thursday. So, let P be any point on the graph y equals x squared minus 8. Okay. Part A, express the distance d from P to the origin as a function of the distance formula. So the first thing you have to do is, what's the distance formula? Okay. Okay. Distance is the square root of x minus x squared plus y minus y squared. And it doesn't matter, those are just two separate x coordinates and two separate y, the two x coordinates and two y coordinates. It does not matter the order because when you subtract one from the other and square it, it doesn't matter which one came first. 3 minus 6 squared and 6 minus 3 squared are the same number. Doesn't matter which one first. Subscripts don't make any difference. Don't get all worked up because you don't have the right point in front. Doesn't matter with the distance formula. You just have your two x coordinates and your two y coordinates. Now, the origin. What are the coordinates of the origin? 0, 0, which is really nice, which means, ooh, this is 0, and this is 0 for our work. So what do we actually have? We have the square root of x squared minus y squared. So our distance is the square root of x squared minus, but what is y? X squared minus 8. It is not y squared. It is x squared minus 8.
Why is it minus in the second one?
Sorry, plus. Yeah, y is x squared minus 8. So instead of having y squared here, we have x squared minus 8 squared.
Sorry, just the step you have before we cross out the ones.
Because what's the origin? 0, 0. So when I plug in 0 here and plug in 0 here, what happens? They go away. So the distance from the origin to any point is the square root of the x coordinate squared plus the y coordinate squared. From the origin to any point. If you change off of the origin to something else, then you need to change. You can't just eliminate those. You have to plug in whatever the x coordinate is and the y coordinate for any other point you use. Yes?
I'm not really following. Do you plug the, so the origin is 0, 0, that to the...
Yeah, if I put 0 here, what happens?
What happens if your origin is 0, 0?
My origin is always 0, 0.
Well, you could...
My origin is always 0, 0.
What if it's not on the origin?
Then you just plug in the other xy coordinates.
Oh, wait, isn't it x minus x?
Okay, shh. Okay. So my distance formula. Let's do this. Chill. Okay. So my distance formula. X minus x squared plus y minus y squared. So in here would be x minus 0 squared plus x squared minus 8 minus 0 squared. Because what is any coordinate that's on that graph? Any coordinate on this graph, any xy coordinate is x squared minus 8. That is what any coordinate on that graph is. Because what's y? Y is x squared minus 8. So any xy point is x squared minus 8. That is any coordinate upon that graph. That is my x and my y. Now, what happens when you subtract 0 and square it? You get x squared. What happens when you subtract 0? You get x squared minus 8 squared. If it's not on the origin or there's a distance, you just plug in something other than 0, the x, y that you're not at. Right? Why did I put in 0? Because it's the origin. If it's not the origin, what do? You plug in the other x, y coordinate. That's all. Okay? Did that answer your question?
Yeah.
Okay. So when you simplify this down, because dear Lord, you want to simplify this down to a workable answer, x squared plus x squared minus 8 squared. Now, if you really want to, really want to, you can take that and FOIL out the x squared minus 8 and then combine up like terms and come up with a single polynomial under 8. There is no good reason to do so. There is no good reason to do so. You can if you want to. It's not the end of the world. Okay, but you don't have to. So here's what you do have to do. First one, what if x is 1? How do you figure out what the difference is when x is 1? Plug in 1 for x and solve it. Really? All you're doing is evaluating it at a 1.
So the guy got it. Yeah. Like, I don't know why they split it into 2 separate questions, though.
Because it's not. There are 2 questions. This is the formula. This is where is it at when x is equal to 1. No, there's more coming. There's more coming. Okay. You plug in 1, what do you get? You get the square root of 50, which is the exact value, although technically we should make that 5 root 2 because we should always simplify our radicals, but I really don't care. But if you were actually working this out on your calculator, you would get 7.071. Okay.
So wait, can it hurry actually be any of those? Or like
Yeah, I really don't want to see this, but I would live with it.
You want mark down?
I would live with it at this point. But really, you should know better. You should know that it should be that.
But that's really, sometimes
you can just type it in the
Okay. Yeah. Okay, now, part C. Use your calculator to graph D, graph that equation, and find the value of x that makes it as small as possible. At where, what is the x coordinate that makes this as close to the origin as it will ever be?
yeah.
No! You've got to plug it in and find it out. Graph that. Find a minimum using your calculator. If you guess, you will get it wrong. The only way the distance will be 0 is if that graph passes through the origin. That graph does not pass through the origin. All right. Okay. So, graphed it up here. You'll notice your graph has 2 minimum points on the graph. Now, are they both legitimate answers? Maybe, maybe not. Here's the thing is, what are we trying to do? We're trying to minimize the distance between them. Either one of these x values could give us the minimum distance. What you need to do is check the x coordinates and compare the y coordinates that go with those x coordinates. If the y coordinates are the same, then it is the same. Then that gives you the same distance because your y coordinate is the actual distance the point is from the origin. X is where it happens. Y is what it is. If those 2 y coordinates are the same, then yes, both of those x coordinates have the same distance away. Not in the same place, but they are the same distance away from the origin. And if you think about a parabola, it makes perfect sense. Okay? So if we go back to here, we do have two answers. We have x equals plus or minus 2.739. And here's what's going on. You need to understand this. I have x squared minus 8. Looks something like that. What they're saying is, I have the origin. I have some point over here. How far apart are they? Is that distance constant? No. As my x and y coordinate on that graph changes, the distance also changes. Where is that point the closest? That's what we're trying to figure out. Because if I'm like, you extend this out up here and I'm up here, the distance gives a lot. The distance here might actually be the closest. I don't know. But we have found out where they are the closest at those two values of x.
My calculator instantly rounded it to 2.74. That's fine, right?
Yeah.
It did it before, but it got like a.
Right. So go to GSolve. I think it's the GSolve. Yeah, it's like a GSolve. And then down at the bottom has all the list of things you're looking for: roots, max, minimums. And then hit the arrows left and right to go back and forth between the minimums.
Well, I did, but it didn't. So like, how do you do it?
Good, because I did it on my Casio, and I got this.
We're doing something different.
Okay. Question number 2. Okay, question number 2. A rectangle is inscribed in a circle of radius 2. Let xy be a vertex of the rectangle. Express the area, let P equal xy be a vertex on the rectangle. So any point on the rectangle xy. So what we're looking for is we're looking for the area of the rectangle as a function of x. So we're trying to find a formula for the area of that rectangle inscribed. First thing we need to do, and we'll need this for both questions, is we have to figure out what is the xy, what is each one of those xy coordinates in terms of x. So what is my original equation? What is the equation of a circle? Yeah, x squared plus y squared equals the radius squared. What's the radius? 2. So that would mean that my original equation, my equation that describes the circle, would be x squared plus y squared equals 4. Right? Now, every coordinate on this circle is x, y. I don't want y. I want everything in terms of x only. No y's, just x's. Okay? That's all I have in my life are x's. So, solve this for y. Subtract x squared from both sides. Y squared equals 4 minus x squared. Take the square root. Y equals the square root of 4 minus x squared. So that means any coordinate on this circle is the point x, square root of 4 minus x squared. Now I need to come up with the area. I need to come up with a formula for the area of the rectangle in terms of x and y. So what is the area of a rectangle? Length times width, right? Area of a rectangle is length times width. So I need to figure out a formula in terms of x and in terms of y for length and width. Okay. If I start here at 0, how far is that distance there? that would be the length of x. For any coordinate, that would be x, right? This distance is x. I go from 0 to whatever my x coordinate is. So what is the length of one side? 2x, because it goes the same distance in both directions. So I would have 2x, or let's say the length. Then I want to do the width. What is the distance from here to here? It's y, which in this case is the square root of 4 minus x squared. But how many of those do I have on one side? I have 2 of them. So this side would be 2 times the square root of 4 minus x squared. That is the formula for the area. Now, I want to make it a little prettier than this. Multiply the 2's, so I get 4x square root of 4 minus x squared. Okay. Part B. Yes.
Okay, the 2x, where did I kind of understand where I'm
Okay.
coming from. Can you explain it again?
What is this distance from here to here?
That is like,
That's x.
yeah.
That's whatever x is. I don't know what
Yes.
x is. It's x.
Okay.
Any size rectangle I have, my distance out is x. How many of those do I have? 2 of them. I have one on this side and I have one on that side of the origin because this is a circle. Whatever distance I go out here, I'm only going to go the same distance there. It's not negative x, so I'm not measuring distance.
Right. Okay. And the other one is
Because I'm going from here up,
we just found y.
and it's the y, and I have 2 of those.
Yeah, I get it. I'm confused on where the original equation.
What's the equation of a circle?
Is the equation-
X squared plus y squared equals the radius squared. Radius 2. Read the problem.
Alright.
Okay. So now, perimeter. The formula for the perimeter is 2 times the length plus 2 times the width, because I have 2 length sides and I have 2 width sides. It's not 2 times the area. Yeah. We already figured out the length. That's the length. So I have 2 times 2x. And then I have plus 2 times, and this is the width, 2 times 2 root 4 minus x squared. And when you clean that up and simplify it up, your perimeter ends up being 4x plus 4 times the square root of 2 minus x squared. Yes?
On a test, if we don't clean it up, we're going to mark down.
Kind of depends. I mean, really, you can't multiply 2 times 2 to give you 4? Yeah, you can. You have your calculators. Oh, by the way, that reminds me, for your test, and this is being recorded, so even people who aren't here will hear this. Some of your tests will be calculators. Some of your tests will not.
We do all of those calculations.
You know, there's stuff that you don't need your calculator for, and there's stuff that we did that you didn't need your calculator for.
So you have like 2 times 2x plus 2 times 2 plus 4 minus x squared, and then when you clean it up, you have 4x plus 4 times, and just turn it into 2.
Is that an accident?
Oh, that was an accident. My bad.
Yeah,
No. Yeah, my bad. My bad. That happens. No. Good. No, please. Okay. That will happen from time to time. And here's usually what's happening when I do that. I'm answering questions and trying to do this, and trying to copy it down and work it all at the same time. I get a lot of stuff going on. Every once in a while, I will miswrite something that's up there. If you think I did that, stop me as soon as you can and try to get me to fix that, because It really sucks if I keep going forever using the wrong thing. When you saw me make a mistake and didn't say anything for 15 minutes. So I prefer that if you think I wrote something down wrong or did something down wrong, that you think I miswrote something or where did that come from? Does it make sense to me? I prefer that you ask. I will either explain it or go, oh crap, I was wrong. Here, let me fix that. And I'd rather fix it before getting carried away. But it's often because I have a lot of people asking questions at the same time I'm trying to do the work here at the same time. And some days, things aren't as smooth as other days. It's life. Okay, part C. Use your calculator to graph those two equations, one at a time, and find the maximum value. Bless you. Because the minimum is very easy to find. The minimum would be 0, or when x is 0, or x is 4, or negative 4 at the edges, because then you'd have no height or no width. Okay.
No, I can't see it. What is it? And why would you
So I have up here both graphs. The one in red is the area. The one in blue is the perimeter. Yes, the maximum area happens in the maximum area and maximum perimeter both happen at the same x coordinate. They're not the same y coordinate. The perimeter and the area are not equal to each other, but they do happen at the same x coordinate.
every time? Do you have to write down the line? Is it every time?
I think it actually will have every time. I think what change the only thing that changes the coordinate is based on the
We
radius.
don't
When you have it inscribed, inscribed within a rectangle, and I believe it actually makes it a square.
Okay.
Because a square is a circle of the square is a rectangle that's the maximum perimeter to area ratio.
So for the first one, we were talking about how if they weren't exactly the same distance apart,
Right. Right. So I want to talk about that. Okay. Let's go back to the notes. Okay. So we ended up with the points x equals, what was it, 1.141? 1.414. Square root of 2. That's root 2. Yeah. That's the square root of 2. Now, yeah, it actually, yeah. Radius is 2. It's the square root of the radius. But that's actually a calculus problem to figure out what it is in terms of r, the radius. We've done that before. So, here's what's going on. That takes us to here. So that gives us an x distance there. Wouldn't it also be the same if it goes to the other side? The distance would be the same going over here. It would work going the same. It doesn't spit out both the plus and minus because we only had x's here being positive. We didn't do anything. If I had thrown the absolute value around this x, I would have gotten both of those possibilities. I didn't because I don't want to complicate it any more than I can. But you have to be smart enough to understand that, yes, the answer according to your graph is over here, but technically the equal distance from the origin to the other side will give you the same answer. Because it doesn't matter which direction you go to establish your x coordinate, it will end up being the same in the end. Yes.
So that's a square.
Yeah, it ends up being a square inside the circle. And it just happens that that's what it is. That's actually, and all three of these problems today are classic calculus problems that when you get to calculus, you will explore them deeper. And you will learn how to find these values without using a graphing calculator to find them for you. You will be able to figure them out in other ways, but you will explore them deeper. They are very common problems. These are classic problems. All three of the ones we're talking about today.
Basically, even though we solved it and got like A, B, and something got still like 4 and 4, even though we did it that way, it still worked. Negative 7 plus
Right. Now, if this was a test question, would I expect you to have both plus and minus? No, but I do want you to understand that going either direction would work. In calculus, I'd want both. In here, not necessarily, but I want you to understand that. Okay? Does that make sense? Like I said, something inscribed in something else, that's a classic calculus problem. Find the distance between a point on this curve and the point on this curve, that's a classic calculus problem. They are straight up. And the next one, oh my God, it is about as classic as you can get. The only thing, yeah, I can't really think of anything more classic than this one. Folding up an open top box. What? Yeah. There's all kinds of stuff that you can do that's really, really cool. Okay. So an open box with a square base is to be made from a square piece of cardboard measuring 12 inches on the side by cutting out a square of side length X from each corner and turning up the sides. So you've got a square piece of cardboard. You are cutting out squares out of the corner and folding up the sides to create the box. What is the distance across the top here? 12, because it's 12 inches across. What's the distance here? 12, because it's 12 inches across, all the way from end to end. What is the length of one side of what I'm cutting out? X. And the length on this side is also X, which makes the distance from here to here. What is that value for that distance? 12 minus 2x, because I'm also cutting x down out of here and out of here. So this distance here is 12 minus 2x. What is this distance across here? It is also 12 minus 2x, because I'm also cutting an x out of both of those corners and out of both of these corners. Okay. When you are finding the volume of a box, length times width times height, right? I have to find the three distances and multiply them together. So my volume. So if I go with this height here first, because if I fold up the sides, how tall is it going to be? It's going to be x units tall. How long is one side going to be? 12 minus 2x. How long is the other side going to be? 12 minus 2x. So when I take 12 minus 2x and 12 minus 2x, I get 12 minus 2x squared. So the length and the width is going to be the same. Okay. So what you're doing, you're taking a piece of cardboard. You're cutting out the four corners. The cutouts are all equal squares. And then folding up the sides to create a box. An open top box. That's what you're doing. So you're folding it up and you're welding the seams together. That's what you're doing. Well, you get the idea. It's called glue. Okay. Okay, what's the volume when you cut out a 1-inch square? So what's the volume when it cut out a 1-inch square? Yeah, plug in 1. You get 100. Yeah, it's 100 cubic inches. Because we're measuring in inches. It does say inches. It does give you inches. I'm not really worried about the units at this point. I'm more interested in the math that finds the units. Okay, what if you've cut out a 3-inch square? Plug in 3.
2, because it's 12 minus 2.
Times 1. I just plugged in 1. 108 cubic inches. Part D. For what value of X is the volume the largest? What are we looking for? Maximum. Good. You should know how to find that by now. Please do so. What do you get? X equals 2. That is the largest value. And once again, if we go back and look at this one, it doesn't fit on here either. But when you're doing this, on your TIs, your graph will look like this. You pop it up, a cursor will show up somewhere on this line when you go to say, I want to find the maximum. Anywhere on this line, you hit yes, you hit enter. And that will give you your left-hand bound. And then you move the cursor over until it will disappear from the screen. It'll go up and then it'll come back down on this side over here. When it pops up over on this one over here, then you hit enter, and that's your right-hand bound, and it will find the maximum that is off the screen for you. You do not need to find the whole thing on your screen. Right, because that's where the graph is. If the cursor pops up here, that means the axis and the graph are nearly identical.
I didn't know that. What?
I thought it was on the graph. That's why I know.
Yeah.
There would be another like bump or whatever. It would show you that, like it would feed into that.
Yeah.
So it shows you when you take a look at it.
Yeah.
Wax and
Okay, let's go back to the notes here. Okay. So I want to talk about this for a second. One of the things that, like I said, this is a classic calculus problem. You will solve this problem, and don't worry, it'll be stepped up, so it'll be quite so easy. And you will solve it using calculus, and you will find the possible places that could be a maximum. But one of the things we talked about earlier this semester was domain and range, was particularly domain. We have domain limits on this problem. Your graph shows you things that could never work. And you have to understand that. What is the smallest possible amount that I could cut out of my corners? 0, which means my volume would be 0. So this one passes through the origin. If I have a 0x, I will have a 0 volume. It passes through the origin. What is the largest amount that I could cut out? 6. If I cut out 6, I basically removed everything. Because if I let x be 6, I have 12 minus 2 times 6, which is 12 minus 12, which means I have nothing. So I have to be somewhere between 0 and 6. I cannot cut out more than 6. I cannot cut out less than 0. And if you look at your graph, it crosses at 0, it crosses at 6, and everything above is good, everything below has a negative volume. We do not have negative volumes, right? Okay, so you have to pay attention to stuff like that. You got to think about that. You got to start being smart. You go, well, I know if you get pops up -3, okay, I can't cut -3 out of my corners. If it pops up as being 11, I can't take 11 out of the corner because I cut out 11 this way. I want to have 11 to cut on the other corner because there'll only be an inch left. It doesn't work. Okay, so you have to understand there are limitations sometimes and be able to use that in interpreting the answers that your calculators give you. You got to be smarter than that tool that's in your hand. Calculators are wonderful tools, but you're the smart one. It's stupid. Your calculator does just what you tell it to do and only what you tell it to do. You have to be able to interpret what it's saying. Okay?